introduce you to Serverless GC, also known as Serverless General Compute. So there's three products under the umbrella of Serverless GC. One is Serverless Notebooks, two is Serverless Jobs, and three is Serverless DLT. I'm going to show you Serverless Notebooks and Serverless Jobs in this demo. And it's much easier to show you than to write it out in a slide deck or an expose and explain what this product is. It's very easy to understand once you see it. So what we have in front of us is a notebook, neither serverless nor classic. It's just a notebook. It becomes a serverless notebook once I attach it to serverless compute. But before I do that, let's put a little bit of code in there so we can see how long it takes for it to start up and to run. So in order to connect to serverless compute, I pull down usually you would maybe select a cluster or a SQL warehouse. Well, here we're going to actually just click on serverless. This is not a particular thing. You're connecting to the ether, you're connecting to this concept of compute. You're not connecting to a particular compute, if that makes sense, right? Whereas here you're connecting to specifically this field eng cluster or the shared endpoint SQL. Here we're saying we want to run this serverless. So I'm going to do that. And let's actually run hello world for us. And we can see that got started real fast, just a few seconds, and I'm able to run a hello world. Now let's do something a little bit more complicated. Let's just select from a table. And we can see that we're basically up and running. We got started in a few seconds. I don't need to go configure a cluster. There doesn't need to be a cluster running ahead of time that somebody else has configured for me. I just go get started. And one of the nice things about this is my experience is generally going to be a good one because I'm not on some shared hardware. So I'm not affected by what other people within my workspace are doing or on that particular cluster. I have basically, Databricks is ensuring that I have a good experience because it makes sure that I have enough hardware to do access to enough hardware. There is still shared hardware behind the scenes, maybe not that important from a user's perspective, but the experience is very good. The other thing I can do, actually, let's show. So this is a relatively small query, right? I'm just selecting 10,000 rows. There's an implicit limit of 10,000 in here. So that's a very small query, right? It probably just read a single file. But let's take a look at this table, and you'll see that it's quite a large table, not that. The more convenient way would probably be to go into the catalog and such. It'd be easier to read, but for the sake of not switching pages, I'm going to do that here. So we're at about 70 gigs. It's a 70 gigabyte table. So let's say I want to copy this. We've already shown that serverless works great for a small query, but what if I want to copy this 70 gigabyte table? It's for the sake of, oh, and also let me show you how big it is in terms of, just copy this so I don't have to keep typing it. Let's see how many rows we're talking about as well. Okay, we're talking about 1.2 billion rows on 70 gigs of data. That's a good sized data set. Now let's say, so I've shown that I can do small workloads. Serverless works fine, starts up in a few seconds, no problem. But what if I want to copy this table? How well does it work on large data sets? This is a problem, right? So if I'm working off of a cluster, my cluster is of a certain size, maybe it's shared. If I make it big, I'll get great performance, but there's a lot of idle capacity. If I make it too small, I'm going to be sitting around for a while. Here we only have 8 cores right now. 8 cores, that's tiny. We're going to be sitting here for quite a while to process 70 gigabytes of data. Oh, but hold on. Now we have, now we're already up to, we're at 16, now we're at 72 cores. It's realized that I have a fairly large workload going. Now we're at 80 cores. It's quickly allocated hardware to make sure that I'm not sitting here forever just copying 70 gigabytes of data. And that's not necessarily costing that much, right? If I'm copying 70 gigabytes of data, whether I do that with 8 cores or 80 cores, uh, it's going to cost a fairly similar amount. It's just going to take a lot longer with 8 cores, right? Because at the end of the day, I need whatever number of CPU hours it is to make that copy, and now we're at 88. I it needs those core hours is what costs money, not the number of hours in the day or the number of hours that I have these CPUs. So basically, it's figured out that I could use more cores for my task. It's allocated me more cores, and probably in fairly short order, it's also going to scale down. And by the way, I'm paying for uh, the CPU time that I use, not the number of CPUs I use, right? So we did that in about a minute and 30 seconds. Let's see how many core hours that took. So that took basically 1.5 hours, yeah, of core time. Now I pay for the 1.5 hours whether I have 1 core or 80. And if I have 1 core for an hour and a half or 80 for, I don't know, for a minute and a half, the price is about the same because I've rented the same amount of CPU time. So we might as well scale it up and get a much better experience. This is saying I moved 60 gigabytes, fine, close enough. Uh, so that's the experience of using serverless notebooks. Now let me show one other thing that I think is very important here, which is libraries, right? So let's say that I have this library that I want to use. This is a real library. It generates data. Let's change this to actually display the results. It generates data for me. It's a Databricks Labs, uh, Databricks Labs project. Uh, yeah, I can't import this because the library is not installed. Well, okay, how do I install libraries? I don't have a cluster. Now I could do the percent pip install. That's fine, but the better way and is to use this environments. And I'm not going to get into all of these because this is an introduction. But uh, what I can do is actually install this library into the environment. This environment goes to the notebook wherever wherever I run it. So if some other user comes in and wants to run it, it will work for them because this environment is attached. If I want to create it as a job, it will work there as well because it goes along with the notebook. So basically, you're defining what are the requirements for that notebook, and that travels with the notebook. They're intimately attached to each other. So now you can see basically that is installed. And what I'm going to do now is, maybe I'm going to take this out so we have a quick running notebook. And let's make a job out of it so we can see what serverless jobs look like. Let's create a job. And so now I'm going to show you the second product, which is serverless jobs. And let's take the one we just worked on, which I have not, remains unnamed. Now, the thing that makes this a serverless job, everything is exactly the same as classic, really. But the only difference is I picked this. At least all the same in terms of configuration. There are certainly some differences internally, and I'm not, again, since this is just an introduction, I'm not necessarily going to get into that. I will put information about that into a slide deck or something like that. But what makes this a serverless job is simply choosing this option, right? I could, of course, choose job cluster and configure it in the old way. I could choose an interactive cluster if I want, but let's go with serverless because that's the point here. And I can use the same environment that I created, so it will install the library for me as well. And let's do that. Let's create that. It's the most basic of basic jobs. That's fine. One thing that is very important when you're creating a serverless job, even for an introduction, is this button right here. So if this button is turned off, if this button is turned on, it will start very quickly. It will also cost more money. If I turn this button off, the job will start slower. It'll take a few minutes, so it'll be much more like a classic job in that sense, but it'll be a lot cheaper. For the sake of this demo, let's show, but some people would ask at this, for the sake of this demo, I want to keep the performance optimized on because I'm demoing it live and I don't want to wait around. As a developer also, I probably leave performance optimized on because I don't want to wait 5 minutes for every test. I just want it to run, but in production, I probably have this button clicked off to save money. And that's going to be true for most workloads for most customers. And some people might ask, well, if it's going to take 5 minutes to start anyway, what's the point of using serverless? Well, there's a lot of benefits of serverless, that are not due to the quick start, such as, Databricks handles the infrastructure. It scales much better. The same, it's got auto scaling in a much better way. You don't have all the various options um, in the cluster that a lot of people make mistakes there. So we're trying to make this a lot simpler, and just simply having serverless makes things work generally a lot better. And also over time, it will improve, will upgrade the software for you. You don't choose the DVR anymore. There's a lot of benefits to using serverless that don't have to do with fast start. So there are benefits other than just starting up quickly. But let's do the fast start for now. Let's actually run this. One of the things I wanted to show you is primarily was that uh, that it will install the library for you. That was kind of one of the primary things I wanted. Now the job does start a little bit slower than the interactive. Not sure why that is today. Of course, it may change over time. So I think it takes about a minute, even in performance optimized, to start up. There we go. It was 30 seconds. And I commented this out and out, so we don't have to wait for it, even though it'll take a minute and a half, but we don't need to be here for that. Okay. And now we can quickly go down, and you see the library came along with it. It was associated with the notebook, and I was able to pull that even into a job. And like I said, anybody who uses this notebook will get that library installed for them automatically, even though they probably won't even be aware. Okay, that's all for today. Thank you.